Hey, in this video we're going to talk all about DevSecOps, what it is exactly, and how you can start using it in your own CI/CD pipeline. We're also going to take these concepts that we learned from the start of the video, and I'll show you a practical example of how we can start using these tools to secure a Docker image. Now let's start from the very beginning here. What exactly is DevSecOps? Well, if the name didn't give it away, basically it's just DevOps with a focus on security. So anything that a DevOps engineer would be responsible for or do, that's the same thing that a DevSecOps engineer would do, but the security engineer is more focused on the security elements. Now on the screen here, I have a lot of different acronyms that security engineers should be familiar with, but don't worry about that for now. What I'm going to do is I'm going to pull up an example of a pipeline, and I'll tell you how you can start implementing these different things into your pipeline, and it'll make it a lot easier to understand what exactly a DevSecOps engineer is doing. But before we do that, let's talk about why we are doing DevSecOps. And when it comes to DevSecOps, we're all about shifting security left. And when we say shifting security left, basically what we mean is moving the security as close to the developer as possible. So traditionally, security was done in the production environment. You would have things like firewalls, access lists, auditing, all those things you would do in your production environment. We still do those things in our production environment, but as we start implementing security into our applications, we are bringing that security all the way down to the code level, to our source code, and to our developers. And when I say developers, I mean the developer's coding environment, so we can actually start implementing security tools into the developer's IDE that can help catch security risks. It can help catch bugs before the developer even commits their code to a GitHub repository. Now, there's tons of benefits when it comes to this shift left security mentality, but the major one is early detection. So early detection, we're able to detect a problem before it gets out to production. So if we're able to detect problems in our staging environment, our development environment, or even in our source code repositories or our developer's IDE, it is very good for our security posture. You don't want to be discovering security vulnerabilities when your code is already out in production. And this leads us to our second major benefit, which is cost savings. So detecting a security vulnerability earlier in the software lifecycle, it's going to be a lot more cost effective to squash that bug, to fix that security vulnerability, than it would be to patch it when it's out in production. So just like the DevOps principle of fail early, fail fast, we have the same principle in DevSecOps is detect early and get rid of that security vulnerability as soon as possible. Okay, so now you know why you're doing it. Let's talk about how you can do it. How can we implement DevSecOps into an existing pipeline? So as a DevSecOps engineer, one responsibility that you're going to have is to secure CI/CD pipelines. So I have a very basic CI/CD pipeline right here that we're going to have a look at how we can start implementing security tools and security processes to secure our application. If you're unfamiliar with the basics of CI/CD pipelines, I have a video that I'll link to that you can watch that I go over all the details of all the different stages of your basic CI/CD pipeline. So having a look at this pipeline, you can see we have the developer's IDE, the source stage, build, test, and release. So going with the concept of shifting security left, let's talk about the developer's IDE and how we can secure this environment. The first thing you can do is you can enforce or just encourage the developers to use certain security tools that integrate into their IDE. So if they're using something like Visual Studio Code, there's a lot of add-ons that they could use that do things like static code analysis. So this brings us to our first security concept in this video, static code analysis. And basically what this does is it has a look at the code and it just checks it for security vulnerabilities. It checks for general coding errors, things that could lead to SQL injection, buffer overflows, those type of things. So it's going to be checking for any type of problem that it can detect without actually having to execute the code. So that's what static code analysis is. And ideally, you're going to be running your static code analysis tools in your developer's IDE. So you'll have them download some sort of add-on that integrates with their IDE. And you can also do it in your source code repositories. So something simple like a GitHub action that runs anytime a developer submits a pull request. You can have that action run a static code analysis. And if it fails, it can prevent the PR from being merged. So that's a pretty common strategy that organizations take. And you're also probably going to run your static code analysis periodically on your source code repositories, because just because code was secure yesterday doesn't mean it's secure today. And that's because new security vulnerabilities are found every day. Now, the next thing you're going to want to do to secure the software pipeline is implement some sort of secret scanner. And basically what a secret scanner does is it scans your code for secrets. So basically it's going to make sure that you haven't put an API key or a database password into your code and push that to a GitHub repository. So you want to run your secret scanners against your source code repositories to make sure no credentials have been put in there. But it's also very important to get the developers to run this in their IDE, because once they submit that pull request, especially if the pull request is going to a public repository, even though it's not merged to the main branch of the code, it's still in the repository, it's still in a commit on that repository. So you actually want to catch these secrets before it even gets to something like GitHub. And the way that I like to enforce this is by using a tool known as pre-commit. And basically what pre-commit does is anytime a developer tries to commit code, it's going to run a set of rules that you have defined. So you can define a rule set in your GitHub repository. And when the developer tries to commit to that, pre-commit will stop them if any of the rules are broken. So with a very basic setup, you can have pre-commit run some sort of secret scanner, and if it detects any secrets, it'll prevent the developer from committing that code and pushing it to the repository. You can also have pre-commit run linting rules, which will basically make sure that the developer is conforming to certain coding practices. And this is something that in general you're going to want to do for any type of pipeline. It's good for just coding practices as well as security. Now, before we move on to the next stages, I want to mention that I've been using the term static code analysis to talk about any type of static code analysis, which basically means things that you can check before the code is running. So it actually breaks down to multiple different static checks that you can run. And these are two of them. So there's one called software composition analysis, which has the same acronym as static code analysis. So it gets a little bit confusing. The other one is static application security testing. And basically the differences between these is software composition analysis is all about checking the libraries that you're using. So it's taking a look at all the open source libraries that your code uses, and it checks those for vulnerabilities. Static application security testing. Basically, this is what I talked about before. It's what's checking your source code for coding errors, things like that. So they are both static types of checks, but there are more specific terms. So I didn't want to confuse anyone with that. I want to mention there's a lot of different acronyms for them, but everything that we've been talking about so far are static checks. Now, another thing that a lot of people get caught up on is they think these checks only happen once, maybe in the developer's IDE or the source stage. Any type of static analysis checks, you're going to want to run in all three stages of this pipeline. So developer's IDE, the source stage, as well as the build stage. And there's a few different reasons for this. The first reason why you want to run it as far left as possible is because you want to detect the problems early and catch them. The reason that you also run them again in the source stage and the build stage is because as your code moves through your pipeline, new security vulnerabilities can be introduced. So during your build stage, there might be an artifact that is introduced into your code that was not there in the source stage. So that's why it's pretty common to run these types of analysis checks in multiple stages of your pipelines. Now let's talk about an item that is pretty specific to the build stage, which is the software bill of materials, also known as the SBOM. So this is going to be an artifact that you generate during the build stage, and basically it's just a list of all the third-party libraries that your application is using. And this is very important and becoming a mandatory component for a lot of applications out there, especially ones that are for government or healthcare. And the reason behind this is because a lot of the vulnerabilities that are found in software come from the third-party libraries that the software is using. So having this list of all the different components that your software is dependent on is a good security practice and likely something that you're going to have to generate for the security team, or if you're the security team, it's going to be something that you want to have on hand. Now, the software bill of materials works closely with your software composition analysis tools. Instead of running these tools directly against your source code, you can actually run them against your software bill of materials. And you're going to want to do this periodically as well, because new vulnerabilities are found every day. And just because everything was secure and there was no critical vulnerabilities a few days ago doesn't mean that tomorrow or next week or next month it's going to be the same. So you're going to want to take your software bill of materials, store them in a repository, something like an S3 bucket, so you can have a look at them and audit them periodically. It's also pretty paramount whenever you hear on the news about the latest vulnerability that comes out, something like Log4j. If you don't remember what that was, basically it was a Java library that had a huge remote execution code vulnerability in it. And when that happened, everyone in the software industry was scrambling to patch their software, but a lot of the problem was a lot of the people didn't know if they were using that library or not. So what the software bill of materials does is it's a single source of truth that you can go to find out which libraries you're using. So when that next big vulnerability like Log4j comes out, you go to your software bill of materials, you just do a control find, and you see if you're using that library, and if you are, which version it is. Now for the next sections here, I'm going to go pretty quick because I want to jump into the demo where we're going to actually implement a lot of these features and technologies that I talked about in a practical example. But I want to cover the test stage and the release stage just really quickly. So during the test stage, you're going to do something known as dynamic application security testing. And basically, this is checking your code during its runtime to detect any sort of problem. So these are the type of checks that you can't run statically, meaning you can't just scan your source code and detect these security vulnerabilities. You need the code to be actively running. So there's tons of different suites that you can use to run these tests, and it's really going to depend on your coding library and what your application does. So if you're running something like an Nginx server, there are certain libraries that you want to run that will do your dynamic application security testing. So just some practical examples of the things your dynamic application security testing is going to be checking for is things like SQL injection, cross-site scripting, authentication, session hijacking, all these things that we can't test for by just looking at the code. We actually need the application running to run these tests. And a pretty common dynamic application scanning tool is going to be OWASP Zap. So if you want to learn more, you can go ahead and look into that tool. And finally, we have our release stage. Well, at that point, we are shipping our software out. So there's not really any security tasks that I like to define in the release stage. Usually everything happens before that. But what happens after that release stage is basically checking your environments. So running image scanners in those environments, running vulnerability scanners in your production, development, staging environments are going to be things you're going to do, as well as scanning your image repositories. So a lot of the time we are shipping our images to something like Docker Hub or Amazon ECR. And those are being stored as an image. And a lot of them you can just enable security on it. And basically what it'll do is it will periodically scan your images. Now, I think Amazon has recently dropped support for their native image scanning enabled on ECR, but there's plenty of third-party software that you can point to your image repositories and it will scan your images for vulnerabilities. That's basically it for securing the software pipeline. There's lots of additional things that you can do and implement, but I think this will get you 90% the way there. And to be honest with you, most organizations don't have half of what I mentioned here. So a lot of organizations can do better on their security posture. And if you implement just a few of these concepts into your own pipeline, it's going to be a lot more secure too. Now let's jump into the practical portion of this video where I will show you how you can actually implement these technologies. All right, so let's get into how we can start implementing the security principles into our pipeline. So I have a code repository that you can clone. The link is in the description below. And in here, we're going to take a simple Dockerized application, and we're going to take this simple CI/CD script that I have here, and we're going to start running security commands on this to scan our image for vulnerabilities, generate the software bill of materials, and I'll even show you how you can take the image and fix the vulnerabilities by removing them and using a more secure base image. So let's go ahead and get started. The only thing you need for this tutorial is Docker Desktop, and you can get that from the Docker website. It's free to use. And Docker Desktop actually has a lot of security commands built in that a lot of people don't know about. So these are known as the Docker Scout commands. I'm going to go ahead and run the CI/CD pipeline just so we get a base image running. We make sure our CI/CD pipeline is working, and then we're going to start using these Docker Scout commands to look at the security of our image. So just having a quick look at our application, basically we have this web app folder. You can see it is an HTML file, and the Docker file is very simple. Basically, it's using the Nginx latest image. It's copying over our HTML to the Nginx HTML folder, and it's exposing port 80. So nothing special in here. It's a basic Dockerized Nginx application, just like one you would see in the real world. Now, if I go ahead and run my simple CI/CD script, basically all this does is it builds the Docker image. I'm using some variables here, but you can hard code everything to the values that you want. This just makes your script a little bit more dynamic. So I'm going to go CI/CD.sh and I'll run that. And this is going to pull down the image if you don't already have it. I already have the Nginx image locally, so it didn't need to do that. And then it's going to build the image, and then it's going to run it. And you can see that I'm getting an error when I run my pipeline. I actually have something out of order here, so I'm just going to fix that. I want the name to be web app, and then this is going to be my image name and then version. So my web app with the tag insecure. I'll make sure to push that up to GitHub so you don't run into the same problem. But if I run it again, you can see that my Docker image was created and now the container is running. And if I just go to Docker Desktop, you can see that it's there. And if I open it up, you can see that we have our application running. Great, so now we have a nice little application. Let's start adding the security components to our pipeline to make sure that our application is secure. The first command I'm going to show you is the Docker Scout CVES command. So let's have a look at that in my larger terminal here. And before we run the Docker Scout command, we're just going to have a look at the images that I have. So I have two images. I have Nginx latest, which I am currently using as my base image. And then I have the image that I created, my web app, that I've tagged insecure, because you're soon going to see that it has a lot of insecurities with it. So let's do the Docker Scout command. And there's a lot of different options with the Docker Scout command. You can see they are all right here. But the one we want to have a look at is CVES, and that stands for Common Vulnerabilities and Exposures. So if you want to check your Docker images for vulnerabilities, you use the Docker Scout CVES command. So let's do that right now. It's Docker Scout CVES, and our image name was my web app, and I want to use the tag insecure, because that's the tag that I have for it currently. So if I run that command, it tells me that I actually need to log into Docker Hub to run this command. So let's go ahead and do that. You can use the Docker login command through the CLI, or you can just hit sign in here. So I'm just going to get signed in and we'll return to the tutorial. Okay, I'm all signed in here, and you can see that my username is showing up, so I know I'm signed in. I'm just going to rerun that Docker Scout command, and it should work now. And this command may take a little bit of time the first time you're running it, but it looks like it was pretty quick for me. And basically you can see that our simple application that is only serving a single HTML file actually has a lot of vulnerabilities. It has 46 low vulnerabilities, 5 medium, 3 high, and 2 critical. Now, if you want to learn more about any of these vulnerabilities, it gives you a link. And this is pretty common for any security scanning software. It'll tell you the vulnerability. Each vulnerability has a name, and then it'll also have a link to a website that you can go to that gives you all the information that you need about the vulnerability. And you could read all about the vulnerability in this documentation, but in this video, I'm going to show you how you can actually prevent this vulnerability from being in your application in the first place. But before we do that, let's talk about how you can block your CI/CD pipelines from delivering the application if vulnerabilities are found. So the first thing you want to do if you want to block your pipeline from creating images that have security vulnerabilities is you're going to want to choose a security threshold. So here you can see that they have ratings for low, medium, high, and critical. So you're going to want to decide what the threshold is for when you actually block an image from going out. So you can see here, there's 46 low vulnerabilities, and a lot of the times organizations let the low vulnerabilities just slip by, sometimes even the medium ones. But usually you want these high and critical vulnerabilities to actually stop the pipeline, to make sure they get removed before the code can actually go out there. So let's have a look at how we can do that. Basically, all we need to do is take our Docker Scout CVES command and put it into our pipeline. So I'm going to go back to our pipeline here and just make it a little larger, and I'm just going to paste that in right after the build command. So I'll paste it in, and basically what it's going to do is it's going to build the image, and then it's going to run that scan command. I'm going to take this variable just so it's more consistent with my pipeline, so I'll just replace that there. And then I'm going to add some additional parameters here. The first thing I want to actually do is just generate this as output. So let's go output. And basically, it's going to generate a file that has all our vulnerabilities on it. You can then set up your GitHub Actions or Jenkins server to email it out or send it as a Slack attachment in your pipelines. The next thing I like to do is I actually like to run the Docker Scout command again, and you can run this in the same command and just add the additional parameters. I just like keeping it separate. It's a little less efficient, but it keeps things a little more simple. But I like to take the output out, and then I like to set a threshold. So I go only severity, and I'm going to say critical. And VS Code is suggesting some suggestions here, but I'm not sure if I trust it. I think what I have here is correct, so we'll try it out. But if I go exit code, this should be enough to get it working. So basically what this says to do is it's going to run the Docker Scout command, and it's only going to check for critical vulnerabilities. And if it finds any critical vulnerabilities, it's going to send an exit code. And since this is a bash script and I have this set -e command, basically that means the script will quit out if any of my commands return an exit code. Basically, an exit code is just an error code, and it's pretty common to make your pipelines fail if any of the commands return an exit code. So let's go ahead and run our pipeline again. And we can see here, it is detecting the vulnerabilities. And you can see in the output here, it was only checking for critical vulnerabilities, and it found 2. So it actually quit out of the pipeline. And if you have a look at Docker Desktop, you can see it didn't get to the end of the pipeline because our image is not running. So our pipeline is pretty good here. We are getting this security report, and it should show up right here. So you can see it's just the output of the security report we generated before. And then we have our threshold set to critical, so our pipeline quits if any critical vulnerabilities come out. Let's now go ahead and have a look at how we can actually secure our application. So the easiest way that I found to do this is to use a more secure image. And you see a lot of people do this using things like the Alpine image. So you've probably heard of the Alpine image before. And basically what the Alpine image is a minimal Linux distribution. So it only takes about 5 megabytes of space. It only has the essential libraries that you need. And basically, the more stuff you remove from your base image, the less security vulnerabilities that you're going to be exposed to. So that's the idea behind using something like the Alpine image. But more and more people are moving to what's known as a Distroless image. And basically, this gives you even less of a security footprint than using something like the Alpine image would. So if you want to learn more about Distroless images, I will link this article in the description below, and you can read all about them. But in this video, I'm going to show you how you can actually make use of them. So we're actually going to be using the Distroless image provider known as ChainGuard. And if you just go to images.chainguard.dev or use the link in my description below, you can make use of their Distroless images. So if you have a look through the list here, you can see all the most popular images that people are using. We have the Nginx one, we have one for Node, PHP, Jenkins, JRE, Go. So basically all the important base images that most people are using as their base image for their software, ChainGuard has a Distroless version of it. So let's go ahead and use the Nginx image, and I have a link directly to this one down below for you to check it out. And here you can see everything about the image, but if you want to just pull it, you can use this docker pull command, or you can just take this URL and put it in your Docker file. So that's what I'm going to do here. And I'm going to go to my Docker file, and instead of going from Nginx latest, I'm going to use the chain guard URL. So it's just cgr.dev/chainguard nginx. So pretty simple change for a developer or DevOps engineer to make. And now our image should be a lot more secure. I'm going to go to the pipeline here, and I'm going to change the version just so we have two versions of our application. So the old one using the basic default nginx image, that's going to be the insecure one. And using the new chain guard Distroless image, we're going to have a more secure image. So I'm going to call it secure. Let's go ahead and run our pipeline. And it's going to go through all the different steps. I don't have the chain guard image on my machine yet, so you can see that it had to pull it down. And now it's building the image. And it'll go through and run the vulnerability checks. And you can see no vulnerable packages have been found. And that's also included in our report here. So that's a pretty significant difference. The first time we ran our vulnerability check using the default nginx image, we had at least 42 low, I think it was. There was a few mediums, a few highs, and at least 2 criticals. But now that we're using the chain guard Distroless image, we've removed all those known vulnerabilities. Now, another thing to mention about chain guard images, if you look at the repository of the image, it actually gives you a lot more information than you would get from an image repository like Docker Hub. So you can see that they have a more security-based mindset when it comes to the images that you're going to be using. So you can see that we have a lot of different tabs here, and one of them includes things like the SBOM, vulnerabilities, as well as advisories. So let's have a look at a couple of these. So if you go to SBOM, you can see it gives you a complete list of the software bill of materials, and you're able to search it. So if you are wondering if the image contains a certain package that you may not want to include on your system, or you're just interested if it is included in your application, then you could search for it here. If you look at the vulnerabilities tab, you can see that this image is free of vulnerabilities. So this is just really great information for a security engineer to have so they can decide if this image is the right one to base their application off of. All right, so the last thing I want to show here is how you can generate your own SBOM so you can deliver this as an artifact to your security team anytime that your new image is created. So this is a pretty standard step you're going to add into any CI/CD pipeline as a security engineer. So let's have a look at how we can do this. So if we pull up the command line again and we just have a look at our Docker images, let's go ahead and generate an SBOM on one of these here. So we're going to use the Docker scout command to do that. So I'll go Docker scout SBOM. And then I want the SBOM as some output. I'll just say my web app.sbom. And then I'm going to input the image name followed by the image tag. So we'll go my web app secure. Hit enter, and you can see that it generated my SBOM. And if I cat it out, you can see that it comes in the JSON format, but you can change the format by giving a different input parameter. Let's go ahead and integrate this to our pipeline. So basically, we'll just take that command and put it into our pipeline here. And I'm basically going to use variables instead of the hard coding here just to keep my pipeline nice and clean. And there we go. Well, I'll go ahead and run it. And basically, this is going to generate my SBOM once my image has been created as a file here, and you can see that it did. So that brings us to the conclusion of our video. I know this one went on for quite a while here, but let me know in the comments below if you have any questions in regards to DevOps or security or integrating security into your CI/CD pipelines. I like to hear back from all of you on what made sense and what didn't, as well as if I got anything wrong or any improvements to anything that I implemented. So let me know in the comments below, and I look forward to hearing back from you. I'll see you all in the next video.